Good day, everyone, from wherever place you're watching from. Welcome to our YouTube tutorial again, brought to you by the academic unit of CCC SP FUTA. Today, we'll be taking Chemistry 102 and having taken the first part, talking about the introduction to organic chemistry, and some characteristics of organic compounds and co. We'll be delving into homologous series, functional group, and a bit of naming today. So let's start with functional group. Functional group. What are functional groups? Functional group, they are a group of atoms, which determines the chemical properties of an organic compound. They are a group of atoms which determines the chemical properties of organic compound. I would like to tell you that let's see, just take functional group as a profession. So when you see someone who is a doctor, that person is an atom that determines some properties about themselves. So when you see a doctor, now what are you expecting from them? You say, oh, this person is knowledgeable, this person should be able to take care of a sick person, this person to some extent should be rich, provided all are being equal. So it determines some things, some values of that person. If someone is called a pastor, you're like, oh, they should be rich in the word of God. Oh, they should be able to nurture the church. They should be this, they should be that. If you hear someone is, an hooligan or a bandit or something, oh, this person should be doing drugs. This person should be this, should be that. And so that is how I want you to take functional group. So when they are in a compound, they can give you information of what that compound can do or what that compound will do. Earlier on, while we were talking about, the characteristics of organic compound, we mentioned something about the alkanes. We said because they have hydrogen bonding in them, and hydrogen bonding supports solubility. So look at the hydrogen bonding. Whenever we now say hydrogen bonding in any compound, it's not only giving you information. So we can say that's a functional group, and that's what we'll be starting with. The OH. This is a functional group. We call them the alkanol. This is not the hydrogen bonding. I'm just saying hydrogen bonding exists in it. So I'm trying to tell you that hydrogen bonding now, you can see, it can tell you some information. It gives you some information. It's telling you this compound will be soluble. This will be this. So anywhere you see OH, there's an information that there's a tendency that this compound will be soluble. If it does not have plenty things that is making it insoluble, definitely it will be soluble. But if it has other things they need to that will make it insoluble, they will not be fighting. Part of it is soluble, part of it is insoluble. So which one will win at the end of the day? So this is a functional group. Another functional group, you have COOH, the carboxylic. Another functional group, you have the NH2, the amine part. Another functional group, you have a lot of them. That's just this, but the few CHO. Let me draw them the way they appear. This is how they appear. This CHO. This is the hydroxyl group. Let me call them the family name. The hydroxyl, carbonyl. The amino, you have the COR. So R will be representing alkyl radicals. What are alkyl radicals? Alkyl radicals, they are a group of atoms, or they are atoms in which one hydrogen has been moved from the parent alkane. Alkane is CnH2n plus 2. Alkyl radicals are CnH2n plus 1. You remove just one from the hydrogen part. So the likes of CH3, C2H5. So I'm trying to explain what alkyl radicals are. They are represented with R. So when you see them, in a chain, we're just trying to tell you that okay, it is alkyl radical. Majorly they are used to lengthen, the chain, like to lengthen the family. So you have alkyl radicals. Sometimes you can see them as R prime. They are trying to tell you it's still an alkyl radical. They are trying to tell you that before you see this one, there will definitely be an R in the command. Let me say I have ROR. So I can put prime here to tell you that this and this is not compulsory. They should be the same. It's not compulsory they are of the same type. This can be methyl, this can be ethyl, this can be alkyl. So it is with I write ROR, you believe whatever idea has to be yellow. So those are just some signatures to that. So sorry for bringing you back again to alkyl. These are functional groups. We have a lot of them. We are not listing everything here. So now let's go to homologous. So you also can do well to find the remaining ones. But of course, we'll be using some of them here as well. So what is homologous series? This is just a group of atoms which determines the chemical properties of their organic compound. But homologous series, it is a family of organic compounds. As I was saying, homologous series is a family of organic compounds. So let me write it down. Family of organic compound which follows a regular structural pattern in which each successive member differ by the addition of by CH2 group. So let me explain. It is a family. Just know that homologous series is like a family of organic compounds. It follows a regular structural pattern, meaning each member in that family, they follow a regular structural pattern. The way they look, they follow a regular pattern. And each successive member, meaning the one that seniors the one, yes, should we use the elder? Now let's say, since we call it a family, so the one that is the elder, the one that follows the elder, let's say the eldest, and the one that follows so what I'm saying is that it is a family, and from the first born to the second born to the third born to the fourth born to the fifth born, there is a regular pattern. So if you pick the first and second born, born, what differs between the two of them is what differs between the second and the third born, and that's what we call a CH2 group. So the other time I said functional group is like a profession, a doctor, a teacher, and co. But homologous series is the family. So when you have the family of doctor, everybody in that family is a doctor, and what they use in senioring themselves is the same thing. The father to the mother, the father is like a 10 years, is like a 10-year ahead of the mother in terms of the doctoral certificate. The mother also, when she got her certificate, it was 10 years ago before the first child got the certificate. And every of them, they are doctors, just with 10 years difference, in the year they got the certificate. So that's something that follows the regular structural pattern. You understand? But it was 10 years in that case. But in this case, it's a CH2 group. So let's pick the families. For instance, a family we have that way is the Alkane. And what is this family known for? They are not doctors, they are not pilots in their own family. What they are known for is a single bond. A single bond is what exists. And in that family, they have CnH2n plus 2. So they have just single bond, and each successive member is by CH2 group. So if the first bond is number one carbon, like CH4, the next one will be add CH2 to it, C2H6. The next one will be add CH2 to it, C3H8. The next one will be add CH2 to it, C4H10. So if you put the formula 4 here, 2 times 4, 8, 8 plus 2, 10, C4H10, the formula also goes. So they differ by the addition. Each successive, don't pick number 2 and number 4 and expect the difference between them to be CH2. No, the difference between them will be C2H4, because you had skipped one. So you have the alkene family as well. They are known for their double bond in between them, just double bond, and CnH2n. You have the alkyne. They are known for their triple bond, CnH2n minus 2. You have the alkanol. So these are the family of this functional group, of the OH group. So in their family, they are having, all of them are OH. Maybe OH represents banker. They are bankers. So OH, CnH2n plus 1 OH. And I just call it, ROH. I told you what alkyl radical. So this CnH2n plus 1 is R, so I can say ROH. Still goes. We have the alkanal. So those ones having this family, CHO. Look at the way it is written, CHO. It's different from alkanol, OH. There is no double bond for O. If I have to draw this one, it's just OH. So alkanal, that is CHO. We have CnH2n plus 1 CHO. That is RCHO. You have the alkanol. That is COR. That will be RCOR. I think you understand what I meant by this now. That is CnH2n plus 1 CnH2n plus 1. You have the alkoxyalkanes. We call them the esters. Okay, so this alkanal, don't be surprised. Another name for alkanal, or a common name we call them the alkanals. Now, a common name they call them is the aldehydes. And the likes of glucose, it belongs to there. The alkanol, another name they call them, they have the ketones. The likes of fructose, they belong there. So let's take another one. We have the alkoxyalkane. Call them the ethers. Alkoxyalkane. And what's their own formula? They are ROR. ROR. And the CnH2n plus 1 OCN H2N plus 1. You can see the difference between alkoxyalkane and alkanone. This one is ROR. This one is RCOR. Do you understand? So you have the alkanoates. That is alkyl alkanoates. Call them the esters. Alkyl alkanoates. So those are the esters. This one is ETH. This is EST. So don't mix it up. So how do you, those ones they have COOR. So alkoxy. This plus stands for the alkanoate fats. When we want to name them, we go to naming. Yes. This stands for the alkanoate fats. This stands for the alkyl fats. So alkyl alkanoate. If I put methyl here and I put CHR here, methyl ethanoate, like that. So what other families do we have? We have the amine family. The amine family. These ones, they are the RCONH2. RCONH2. That is CnH2n plus 1 CONH2. You know, R stands for this. You have the amine. That is RNH2. Ethylamine. What else? Another family that you have. You have a lot of families. So just do well to you have the TO. That's when S is replacing O in esters and O. So a lot of families. Now let's go to before we move to the next thing, let's talk about homologous series. Some information is given because homologous series carries information. I told you it's just like a family. So if you know what one member in a family can do, you can easily predict or tell other things the family members, other family members can do. So for instance, number one thing homologous series, the information homologous series passes to us is that general molecular formula. So homologous series passes that information of general molecular formula to us. That is, every of them has same formula. It is the alkane, this is the general formula for them. Alkene, this is the general formula for them. So that's one of what homologous series does. Another thing homologous series does is similar method of preparation. Similar method of preparing them. So if you know the method of preparing one of the member in that family, you can still tell the method for preparing higher members of the family or other members of the family. For instance, let's look at the likes of alkene. To prepare ethene, you can just dehydrate ethanol. That is removal of water from ethanol to get it. Now to get propene, C3H6. How do you think you can get propene? Similar. So it means probably if you ferment propanol. I'm just using this to give an example that is, that homologous provides you an information that you can easily tell. Let's say you are lost now somewhere and they ask you that what's the method of preparation of propanoic acid and you don't know any method, but you know that of ethanoic acid. You can still formulate, permutate. So that's by the way. The next one is we have similar chemical properties. So they have similar chemical properties. If you know the chemical properties of one, there is high probability that another member in that family would have that same properties. For instance, combustion. Alkane families, they combust. So if methane is combusting, you know that ethane too can combust. That is, it burns in oxygen to give what methane will give. That is water, vapor, and carbon dioxide. And that's the same thing methane will give. That's the same thing ethane will give. That's the same thing propane will give. Like that. So the next one is their physical properties. They don't have similar physical properties. The physical properties, properties varies gradually. That is, it changes bit by bit. For instance, if you look at the alkane family now, the alkenes. If you look at them, the first 5 elements, that is methane to pentane, they are gases. If you go down from 16th to like the 17th member, so from a very light gas, dense gas, gradually start becoming liquid. The forces in them start getting stronger. So 6 to 17 are liquids. The forces in them become very strong at some point, and it turns to solid. So the likes of the higher members like ecosane, that is the 28th member, 21st, 22nd, and co. They are solid. So we've spoken about general molecular formula. Okay, the next one is each successive member. This one is common. Each successive member, they differ by the addition of the CH2 group. Each successive member successive members differ by the addition of a CH2 group. So even if you don't know, let's assume this is a compound you don't even know, but this is ethanol. If they ask you that what will be the next member after ethanol, if you don't know anything at all, just add CH2 to it. Then you have you have CH3, CH2, CH2. Then this is propanol. So you can tell the 10th member, just keep adding CH2, CH2. So these are the combinations homologous series, provides. Now let's go to naming. So for naming, there are usually 3 different classifications of naming, or 3 different types of naming of organic compounds. Since we have them now, you see that I was mentioning some names the other time, so that you will not be confused on which one am I talking about. As I mentioned the name, you should know what I'm referring to. There are 3 different ways. The first one, they call it the trivial. Some call it the common name or trivial naming. Just be common. So this system of naming is usually gotten from a place of derivation, where you are getting that compound from. So they name it from where they get the compound from. For instance, formic acid was gotten from I think ants. We call them formic or something like that. Yes, that was where they got the name formic acid, because you are getting it from them. Formica. Yes, formica. That's an ant. Formica. You have acetic acid. Acetic acid was gotten from aceton. Acetic acid, that's vine, from vinegar. Aceton. They call that aceton. Maybe the Greek name. So aceton. And the likes of wood alcohol. That is methyl alcohol. It was called that because it was gotten from wood alcohol. So let's go to another system of naming. We have the semi-systematic. This is a combination of the common name and the systematic naming. So it's a combination of using the old name or using the common name, then the internationally agreed naming system. So that is when you have likes of methyl, let's see, isopropyl. I see names like this, isopropyl and co. They belong to systematic naming. But the last one, systematic naming, this is the IUPAC nomenclature. IUPAC stands for International Union of Pure and Applied Chemistry. So a body came together and they decided, okay, for us to name organic compounds, so that when you see it in Canada, when you see it in another country, when you see it in this country, you would know that, okay, this is what I meant. So they came together, because not everybody understands formic now, and not everybody knows where these things are derived from. So they agreed to a system of naming and systematic, and that is what we will be doing up next. So systematic naming. How do we name systematically? There are different tons of rules, where you have to, that you have to follow. But I'll just call out 4. Along the line, we might be using some extra ones, but the 4 major ones that I want you to follow through, that I'll be using to name almost every compound we'll be using here, or we'll be using to name compounds we'll be using here, every compound, are just these 4. So just follow through. The first one is just keyword. Locate the family. Let me call it that. Select the chain. Select the right chain. I won't call it either the long or the. Select the right chain. Talk about the substituent. Let me call it locate the substituent. Okay, the substituent. Arrange properly or alphabetically. Arrange properly or alphabetically. So in case you do not see what I wrote here, locate the family, select the right chain, locate the substituent, arrange alphabetically. So now we'll be taking the IUPAC nomenclature of the following you've seen here. These are their structural formula in compact form, in condensed form. There's the way they call it. So first, what we'll be doing is we'll be separating. So we are going to take a lot of this so that you would understand better the concept, behind naming. So this one, we have CH3. The first thing you can, stretch it out, 2 C's, 3 hydrogen. So nitrogen should be 4 bonds. So 1, 2, 3, 4, 1, 2, 3, 4. So 8 here, 8 here, 8 here, 8 here, 8 here. So 8 here. So C3H6. And you know this one, since it is single bond all through, you know what family belongs to. That's the alkane family. And 2 carbon atom in the alkane family, that is F. That's ethane. Are we good to go? Now moving on to this CH3. You know, and you have CH2 in 6 places. That is C in 6 places. 1, 2, 3, 4, 5, 6, then CH3. So this is CH2. You know, 6 of it. Because this C is already having a bond here. So it's only 2 bonds left for bonding hydrogen. That's why you have CH2, 6 places. Do you understand? So you have H, 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 H. So single bond up through the alkane family 1, 2, 3, 4, 5, 6, 7. So if you have to follow that rule I gave you, I said first select the family. What family? Since it's single bond all through, that's alkane family. The next thing I ask you to do is select the longest chain. This is the only longest chain. That is the longest continuous chain that still bear their family's name. This is it. Chain means carbon atoms you can trace from beginning to the end as the longest in the whole of your structure, and this is it. There is no, so the third one is your substituent. There is no other substituent. Substituent means other elements, not hydrogen now, other elements aside your carbon, you know, aside the chain, other elements that you can trace, either long chain or short chain, aside your main chain. This is your main chain that bears the family. So there is no chain again, there is no line going up or down. Do you understand? Don't worry, as we proceed, you will get it. So since we don't have, just name it 1, 2, 3, 4, 5, 6, 7. So this is 1, 2, 3, 4, 5, 6, 7. It should be 8. So just bear the. So this is the first CH3. This is 1, 2, 3, 4, 5, 6. These are the 6 CH2s. Then another CH3 at the end. So here you should have octane. That is 8 carbon atom. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon atom. That's octane. Then let's move here. So I want you to follow through very well. CH3. That is CH3. The next CH2. That is, this links to another C. 1, 2, 3, 4. You leave this bond for the next thing it will attach to. Then H2. So you fix this. The next is C. You leave another bond for the what it will be attached to. So it has CH3 too. You know you cannot put CH3 here because this bond is left for another C that it will link to. So it means the remaining 2 bonds it has here. That is where you can fix this CH3. So CH3 on one side, CH3 on the other side. Do you understand? So if you want to draw this one, you know, in the spread out form, C, it has 4 bonds. The one that links it to here, and the remaining 3. So that is where the H will hang on to. So when you see CH3 in bracket, not CH2, CH3 in bracket, you should know it is a substituent. It will not be on that chain because there is no space for it to be on that chain, except it is the last CH3. Look at this one is the last CH3, so it will be on the chain. But if you see CH3 inside, carbon only has 4 bonds. So don't try to get from the left to get from the right. So it will only be left with 2. So there is no how you want to fix CH3 in it. I don't know if you get that explanation, but what I'm saying is when CH3 is in bracket and it is not the one at the end or the one at the left side, you should know that it will be a substituent. So this C now, this is it. It is linked by the left side bond. It will ask right side bond to link to the next thing, and it's still having CH3 too at the front. So it means the remaining 2 bonds that it has, that's where you add the 2 CH3. Do you understand? Now let's go. We are done with this part. The next thing is C. So this C was introduced by this bond. It would also link to another one. Then these are remaining 2 things for it, to add. Since carbon is tetravalent, 4 valence electrons. So it has H2 at the front. So definitely we know the H2s will be 1 here, 1 here. Then this last one is CH3. So you see that it is not linking to any other C. That is why it is having 3H. Do you understand? So let's name this now. So what did I do? CH3, a bond to link to this C, link to this C, and it has H2. Just so that a carbon atom, provided it is not at the start or at the end, it only has 2 bonds. It only has 2 hands for bonding. Except if it has the last side, that is when it has 3 hands for bonding. The one that links it, up, down, and the other hand. But if it is at the center, it only has 2 bonding. So that's why it is either having H2 for those 2 bonding, or CH3 for those 2 bonding, or sometimes it can be CH. Let's assume this is CH3, CH, CH3, CH2, CH3. So this English now, you see this CH3, it is the one starting, so it can have 3 bonds to exercise itself. It links to this one, see? This one links to another one. So this one has just 2 and to bond other things. And what are those 2? What are those things to bond? It has H here and it has CH3 here. Do you understand? So it could either be CH3, 2 of it up and down. It could either be H2 up and down, HH. It could either be HCH3, HCH3. It could either be CH3Cl, CH3Cl. It could either be Cl2 and ClCl. Do you understand? So that is that on that. So now let's move on to naming this one. The first thing is you select the family. What's the family? Single bond of 2. That's the alkane family. Then name the family. Immediately you select it. So let's see. No, the second one is the longest chain for that family. 1, 2, 3, 4, 5. That's 5. What if you go 1, 2, 3, 4? You know, it's like a game. You can go straight before you fall into the pit. The longest travel you can travel before you reach the end. Either you go straight this way, 5 carbon atoms. You count the carbon atoms, 5 before you reach the end, or you go this way 1, 2, 3, 4 before you reach the end, or you go this way 1, 2, 3, 4 before you reach the end. So out of everything, this is still the longest, 5. Or you go this way 1, 2, 3, 4, or 1, 2, 3. So the longest is this one, 5. So since you've gotten the family and longest chain, name the family. So the longest is this, that is this one, and that makes it 5 alkanes, pentane. Let's get it closer, pentane. So you have gotten the family, select the longest carbon chain. Then the next thing is what's the next thing? The next thing is your substituent. So what's your substituent? Your substituent means other carbon or elements aside hydrogen that you can still see on that chain. Now that you can see, but it's not on that main chain you pick. This is the main chain you pick. So other carbon atoms you can see that is not on that main chain. Where are they? Now this is a note for you that whatever chain you'll be selecting, you must make sure that all other substituents are putting their leg on that chain. When we get there to where we need it, you will see. All other substituents you must select, they must have their leg on that chain. Meaning, look at this carbon. The leg is attached to the chain. Although it's not part of the main chain, but it is having something linking to this chain. It is having something linking to this chain. Do you understand? Don't worry, don't let me complicate things. When we see examples like that, you understand better. So we've selected the longest carbon chain, the family, then the substituent. So this is a substituent because it has carbon in it and it is not in this chain. Its leg is just attached to the chain. The same thing with this C. It is out of this chain, but its leg is attached to it. So those are substituents. So what are the name of the substituents? CH3, alkyl radical. If you remember, we treated alkyl radical. CH3 is an alkyl radical. That is an alkane where one hydrogen has been removed. C2H5 is an alkyl radical ethyl. C3H7 propyl, and so on and so forth. So these are alkyl radicals and they are methyl. So let's get the position of those. These substituents now. I want to talk about that substituent. The position. Where is that substituent found? For instance, if I give you, what amount of money do I need to give you for you to get here? If I give you 2 naira, it means you can only take 2 steps before you get exhausted, before you use the money. Before the money got exhausted. So how much can I give you for you to get here? So from the front, if you are going through the front, yard, 1, 2, 3, 3 steps. From the back, 1, 2, 3. Do you understand? Both are found in 3, 3, in position 3, 3. Do you get? So you can go from the front, you can go from the back, because your family is not mandating that. You can either go from the front or from the back. The family is flexible. Okay, families are flexible because they are single bond of 2. So if I had gone from the back to name it pentane, you will not know. If I had gone from the back to name it pentane, it's still 5, and single bond of 2. Okay, you would understand when we get here. So for alkane, you are free to go because the front looks like the back. Do you understand? This chain you select, you can turn it. It still looks the same thing. I'm not talking about the substituent. Just this chain alone. It's still the same thing if you turn it. So now let's go to substituent. This substituent now, it is methyl. It is on position number 3 from the front. This one too is on position number 3 from the front. So both are 3, 3. From the back, it is on position number 3 from the back. It is on position number 3 from the back. So from the front, they are both 3 and 3. From the back, they are both 3 and 3. 3 plus 3 is 6. 3 plus 3 is 6. So the two of them gives the same number. So you can pick any position, either from the front or from the back. So let's just go from the front. So it means since they are the same thing, we have 3 One is in position number 3. The other one is in position number 3. Dimethyl. That is 2-methyl. 2 methyl. We have 2 methyls, and this is their position. 3. If they were 3, I would say trimethyl. Then you have to give 3 positions. Now note the way it is written. Between a number and a number, you have a comma. Between a number and a letter, you have a dash. You understand? So 3 dimethyl. So if I'm using, if there are 3 of them, I'll say tri, and I can say 2 3 3 or 1 2 3, depending on the position where they are placed. 1 2 3 trimethyl. If there are 4, 1 2 3 3, 2 2 3 3 or 2 2 4 4, tetramethyl. Do you understand? So that's by the way. Let's continue. The more we take examples, the more you get to understand each other. So you have CH3, CH, CH2, CH3. So now let's draw this structure. We have CH3, that is 4 bonds. Fix your H. This one links it to the next one. That is your C. It links to the next one. So there are 2 bonds available. Out of those 2 bonds that are available, H takes 1. Then definitely, this one in this bracket is what would stay here. And that is CH2, CH3. Don't worry, you see how we expand that. Then the next one is what? This C, links to the next one. Then you have H because it is H2. Do you understand? Then this C, this last C takes H3. So if you count the number of bonds every carbon has, it's 4. 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. Are we good to go? Now let's see the carbons there. Do they have 4 as well? So C, they call it CH to CH3, or better C to H5. Now let me drag it down. So C and another C. You understand? So C H. So CH. Now let's name this. The first thing is the family. What's the family? Alkane, because it's a single bond all through. Do you understand? So single bond all through. What's the longest chain? Once you know the family, the longest chain. 1 2 3 4. This is one chain. That is, if you start from here, you end it here. Another chain you can pass through is 1 2 3 4. That's another one. Now the next chain you can pass through is just like a game. If you are the type that likes playing games like this, you would have easily gotten the longest chain. 1 2 3 4 5, or 1 2 3 4 5 is the longest chain. If you like, go like this. So far it's still continuous, longest continuous chain. So the largest so far is this 5th one. So let me just circle it. And this is what we are going with, longest continuous chain. Do you understand? So you would see that you have single chain of 2, single bond of 2, and 5 carbon atoms. So what family is that? Alkane, 5th member, pentane. So that's pentane. Now once you get your family, you go to the substituent. So the substituent, that is the one that is not in the chain, but it is a carbon or a chlorine or something else. So let's go. This one, that's the substituent. So what is the position? So either you start from this place or this place as you're counting. From here, 1 2 3. It's on position number 3 from, I call it the front now. From the back, 1 2 3. It's also on position number 3. So what is that? That is 3 3 from both front and from the back. Let's just pick one. And that's the lowest one. So we don't have the lowest one since both of them are the same thing. Magnitude. That would be 3 methyl. Since it's just one, you don't need to call it monomethyl or unimethyl. So it is 3 methyl pentane. So I want to make some modification to this same question to show you something. Okay, so this is not part of the question, but while doing this, there was something that popped, that popped up, and I thought, okay, let me create an example for you to understand. I know the other time I was saying the longest chain you would pick, the long continuous chain you would pick, has to have every substituent in it. For instance, look at, so that you understand that statement. The first thing, alkane, because that's the family, everything single bond. The next thing, you pick the long continuous chain. Look at the long continuous chain. 1 2 3 4 5 6. Yes or no? 1 2 3 4 5 6. 1 2 3 4 5 6 7. So which one is the longest? This 7th, right? But if you take this, you are wrong. Why? Because look at this substituent. Look at the substituent. What are the substituents? Substituent means other things that are not in the chain. This carbon, this one, they are the same. Carbon, carbon, they are the same. So you can call it just a single substituent. This substituent is linked to this chain. But look at this chlorine. It is also a substituent. Is it linked to this chain? No. It is linked to this carbon that is not part of the chain. So you have two substituents. You have the carbon substituent, you have the chlorine substituent. But the carbon substituent is linked to the chain that you picked. The chlorine substituent is not linked to the chain. Instead, it is linked to another, substituent that is linked to the chain. So you cannot go with such chain because every of your substituent has to be linked to the chain. So instead, what do? We are not going with the longest one because it's long. You have to go with the one that is long yet has every substituent attached to it. So we can go for one of those 6. So this 6, let's go for this one. Now look at this one case. Your substituent chlorine is attached to a carbon in the chain. Your substituent propyl is attached to a carbon in that chain. So you can see this is the chain, and your substituents have roots attached to that chain. You get what I'm saying now? So it's not just about the lengthiest. We are going to name this. It's not just about the lengthiest, line, if that's what we call it, but the longest that would have other substituents attached to it. Do you get? So now let's name this. So since we are going for this chain, that is X, 6 member in the N family, hexane. Now the substituents, this is substituent 1, substituent 2. You have chlorine, that is, we call it chloro, that is the substituent, and you have C3H7. This is propyl, an alkyl radical. So propyl. Now their positions from the front alkane, you are good to go either front or back. Alkane does not give you issue. So from the front, 1, 2. Chlorine is 2, 1, 2, 3. Propyl is 3. From the back, 1, 2, 3, 4, 5. That's if you want to take your jumping from the back. Carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. Chlorine is on carbon number 5, and propyl is on 1, 2, 3, 4, carbon number 4. So your front calculation 2 plus 3 gives you 5. Your back calculation 5 plus 4 gives you 9. Imagine when you have, there's a short route you can take that you just spend 15 hours to get there, and there's a short route, there's another route you can take that you spend 19 hours. Which one will you pick? You say 19 hours. But when the time comes to price short now, so you are going with the short one, are we good to go? So it means the front wins because that's the lowest number of steps you can take. So it's not even 3, it's 2. 2 and 3, yes, 2 and 3, 5. So 2, 3. So 2 chloro and 3 propyl is what we are going for. So this is where the 4th thing I wrote for you under the steps for naming is. You arrange alphabetically, not with number, the alphabet. This is C and this is T. Which one comes first in the alphabetically? That's C. A, B, C, D, E, F. You have so you have 2 dash, between number and letter. 2 chloro, 3 propyl. 2 chloro, 3 propyl hexane. Are we good to go? Are you sure?